Welcome back, guys. It is time to go over our review workbook work that we've done this past week that you've been working on and this past weekend. We are working on weather. I gave you credit if you gave it your best shot. I did not go question by question and correct them based on scientific validity, but this is your turn, your chance to check your work. Make sure you understand if you got something wrong, why you got it wrong, so you don't make those mistakes in the future. Okay, so we're going to start with page 38. Okay, so we have the weather graph. It's called the weather factors. The weather graphs show data recorded at Syracuse, New York as a winter storm moved across the region between December 1st and December 4th, 2007. Year I graduated high school. Woohoo, I'm old. Okay, graph 1 shows air temperatures and dew points. Graph 2 shows barometric pressures. Okay, so on this graph we got temperatures in Fahrenheit, it says, and we got dew points. Okay, what is the dew point? I know we all know what temperature is, but just a quick reminder, what is dew point? Dew point is the temperature that the air must reach for it to be saturated, for it to be full. And you'll notice that the dew point is always below, or at the very most, it's equal to the air temperature. The dew point is always going to be lower because colder air holds less water. So it's easier to fill the cold cup. The cold cup is smaller. Remember that from our lesson. Okay. And if we have this barometric pressure, okay, we have this in millibars on the left, okay, and it rises and falls and rises again, okay. Interesting. So number 1, you're just reading right off the chart, a relationship. State the relationship between air temperature and barometric pressure in Syracuse on December 2nd. Okay, so we're looking just at December 2nd here. So December 2nd here, as temperature goes up on December 2nd, oh sorry, I was looking at dew point. As air temperature increases, barometric pressure decreases, okay? So that was just reading straight off the chart. You don't have to know anything about these actual terms, pressure and dew point and all that to do that one. Or you could have said it's an indirect relationship, an inverse relationship, okay? Yeah. Number 2. On which date and at what time did the relative humidity reach 100% in Syracuse? Explain your answer. Well, that has nothing to do with pressure. So we're going to be looking at this first graph up here, temperature and dew point. And remember, when the temperature hits the dew point, when they are equal, that means you are 100% full. When you hit the dew point, you're full. So there's only one place where the dew point and air temperature are equal, right here. So if I go down, that's December 3rd at 4 p.m. Okay, and that says December 3rd at 4 p.m. when the air temperature and the dew point temperature were equal because you're at saturation. Okay, saturation means you're 100% full. Okay, number 3, convert the air temperature and dew point temperature at 12 a.m. on December 2nd into degrees Celsius. Okay, so they put it in Fahrenheit. So this is just a converting question, an ESRT question. So dew point, temperature, and air point on 12 a.m. December 2nd. Okay, 12 a.m. December 2nd. 12 a.m. That'd be right here, okay, because this is the start of December 2nd. This 12 a.m. would be the start of December 3rd, okay? So this is the start of December 2nd. I go to, let's do the air temperature first, okay? Here, I read over. So 26 degrees Fahrenheit, and for the dew point, 22. So 22 and 26. So I'm going to go to my ESRT, my handy dandy ESRT. Okay, we're going to go to page 13. We're going to go here to my Fahrenheit, Celsius, Kelvin scale. Remember, Fahrenheit goes up by 2s, Celsius goes up by 1s, and Kelvin's goes up by 1s as well. And all that talking, I forgot the numbers I was supposed to be looking for. Go me. Okay, hang on. 26 and 22. Yeah, okay. All righty. Whoop. Nope. There we go. 26 and 22. So 26 Fahrenheit. So I'm going to zoom in. So that's kind of the nice thing here. I can zoom in. So 20, 22, 24, 26 right here. If I scroll over, okay, that is below freezing. Okay. So it's right here on this line. I'll leave my cursor there. So 0, -1, -2, -3. Okay, -3 Celsius. And for 22, if I scroll over, it's not exact. It's kind of in between these two. So I would say, well, -1, -2, -3, -4, -5-ish. Okay. So sometimes it's not going to be dead on, but the regions would be really lenient with that because they know. Okay. So air temperature is -3. That's what we got. And dew point is -5. Just make sure you have your degrees C on there. No naked numbers. Okay. Oh, we got another converting question for number 4. Convert the barometric pressure at 4 p.m. on December 1st into inches of mercury. Okay. So we got to use our ESRT again for barometric pressure 4 p.m. on December 1st. December 1st, 4 p.m. barometric pressure. I go up. Okay. Let's zoom in here. This point right here. Ooh, that looks not good. Okay, if I read over, boop, right here, this line, it looks like they go up by 1. So 1034, 1035, 1036, 1037, 1037.0. Okay, 1037.0. We got to go back to our ESRT, 1037.0. I got to say it 9 times because I forget. Okay, 1037.0. Okay. Let's look. Now I'm over here. Sorry, I can't zoom anymore because I'm dumb. All right. Oh God. Spinning wheel. What'd I do? Oh, I can zoom in more. Look at that. So we're doing millibars to inches of mercury. So 1036, 1037, 1038, 1039, 1040. So we want 1037, which is right here. If I scroll over to inches of mercury, I have to first off know, what the heck is this going by on this side? Okay, well, if this is 30.6 and this is 30.7, it must go 30.61, 30.62, 0.63, 0.64, 0.65, 0.66. So it's actually going by 0.01. So if I go here, I go over, that would be 30.60, 30.61, 30.62 inches of mercury. Okay, we're going to be watching a video later this week coming up about how a barometer works, so that inches of mercury thing will make a lot more sense. Okay, so it's actually a video called How a Barometer Works. So what did I get? 30.62 inches, is that what I got? Yes, it was. Okay, so if you had any questions on this, you can add them into the comment section of this video. Okay, let's move on to page 39. A lot of you had problems with this page, and I understand it's really difficult, but I think a lot of you are overthinking it because you saw this picture and you were like, whoa. Okay, you don't even need this picture to answer the questions. It's just showing you high pressures and low pressures. Okay, like on the weatherman when he does the news. Okay, so it says the map below indicates an air pressure field over North America. Isobar values are recorded in millibars. Okay, fun fact, well, not fun, but it goes by usually by 4s. So 1020, 1016, 1012, so 4 millibar increments. Okay, so all you had to do was compare high and low pressure. You don't even need to look at this. Okay, now this one you have to remember what we learned in the video lesson before. Okay, high pressure, temperature, happy, high, cool, and dry. Happy, high, cool, and dry. So the temperature is going to be a little bit cooler. Humidity is going to be drier. Okay. Then remember, lousy, low, warm, and wet. Wet, moist, whatever. Okay. So it's a little warmer during a low pressure system, and it's a lot more rainier. Low pressures are usually when you get your rain. Okay. So cloud cover, high pressure, low to none. Because high pressure is when air is sinking down on you, sinking down. Vertical is moving down. When air goes down and pushes on you, okay? you're not going to have rising, expanding, condensing. So you remember, if you have sinking air, you're not going to have clouds. And if you don't have clouds, you're not going to have precipitation. Okay? And when that air sinks and sinks and sinks and it finally hits the ground, it's going to spin outward and in a clockwise direction. Okay? So remember, the winds blow from, the high would be right here where my cursor is, they flow from the high. So notice how they're leaving, they're going away from the center here. Okay, so the air comes down here and spins outward and clockwise. That clockwise you just have to kind of memorize, okay? Hopefully this makes a little bit more sense now. Let's move over to low pressure again. So lousy, low, warm and wet. The cloud cover is high because low pressure means air is rising off your shoulders. It's releasing the pressure because all the air is rising. That's less pressure on you, low pressure. So rising air, what does rising air do? Think of the yoga move, rising, expanding, cools and condenses. And when you have condensation up there, what are you going to get? Clouds. And if you have lots of clouds, you're going to have much more chance of precipitation. Okay, so those are kind of make sense now. Now, look at my cursor right here, air rises off this point. Okay, rising. If you're standing right here in the center, and remember, air flows away from the high and to the low. So it flows inward towards the low, and it actually flows in a counterclockwise direction. Okay, so like I said, clockwise and counterclockwise thing you kind of had to remember. But the inward and outward thing is, just think if there's an H here in the middle, flows from the high, and if there was an L here, to the low. Okay, hopefully that makes a little bit more sense. I think people were trying to use that picture up here, and you guys got really confused with that. Okay, this is just literally information from your notes. Okay. All right, let's move on to page 40. One of my favorite lessons that I didn't get to teach you, I'm sad, okay, about winds. Okay, there's a couple different kind of winds. Remember, we name winds from where they blow from. So it says, label the two lines provided on the cross-section below to show where Earth's surface air temperature is relatively warm and where it is relatively cool. Now, you got to be careful. This is a clear summer afternoon, so there's the sun. Okay, we have water and land. And we should know ocean water has a very high specific heat, so it takes a long time to heat up. But the land is going to heat up real fast. So the temperature compared to the ocean, the temperature of the land is going to be warmer. And compared to the land, the temperature of the water is going to be cooler. Okay? So now we have to do the two lines provided to show where air pressure would be high or low. Well, you know this if you know convection. What happens? Cool things sink down. Okay, cool things sink. And if air is sinking on you, that's adding pressure, high pressure. And right here on the land, if it's warm things rise up. And if you're rising up, you're taking pressure away from your shoulders. That's low pressure. Okay, so that's literally, this is just a convection cell. Okay, it just goes up and around and around and around and around, okay? It says draw an arrow on the diagram between the ocean and land to indicate the direction of the breeze. Well, winds always blow from the high to the low, okay? So this would be the wind would be coming off of the water and going towards the land. So we don't call it an ocean breeze, we call it a sea breeze, okay? And that happens during the daytime. If you've ever been to the beach during the day, it's very windy. Honestly, anytime near the beach, it's really windy because you have such a stark difference between your ocean and land. Okay, so that's why the beach is always so windy. Okay, now what if it was nighttime? Okay, now it's a clear summer night. So now we have to do the same thing. So let's go. Now the ocean has had all day to warm up. So it's finally a teeny bit warm. So, and then the land, because of its low specific heat, it's cold now. So it's going to be cool immediately. Well, not immediately, you know what I mean? Compared to water, okay? So the temperature of the land compared to the ocean is cool. And now the water's finally warmed up from the day, so it's actually still a little bit warmer, Okay. And remember, this is compared to the land. It's not like it's going to be boiling hot or anything, okay? Comparative. Now, once again, same thing. Warm things rise, low pressure, taking the air off of my shoulders because it's rising away. Over here, cool. That was cold things, sink. And if air is sinking on top of me, pushing down on me, that's high pressure. Winds always blow from the high to the low. So that would be a land breeze because it's coming from the land. Okay, so if you ever wondered why the beach is so windy, well, that's why. Now you know. Okay, this one is just a straight up weather instrument. Identify the name and what does it measure. Okay, they do ask this on the regions. I know you don't have to take the regions this year, but they do actually ask it straight up. What does an anemometer measure? What does a barometer measure? So on and so forth. So number one, this is a mercury barometer. Okay, you have mercury in a tube. It pushes things down. You could tell because it says inches of mercury. You should easily know it measures air pressure. Okay, it's called a barometer. It's in our notes. This thing with little cups on the end, I have one in our classroom. Okay, when you blow into it, the faster the wind blows, the faster it spins. Okay, that's called an anemometer. And it measures how fast the wind goes, wind speed. Okay, the thing with the rooster on top on most barns and cartoons. Okay, the arrow points in the direction that the wind is blowing. So that's called a wind vane, and it measures wind direction. I think we all know thermometer measures air temperature. Okay, number 5, we saw this picture in our notes. It's just a weird, it's two thermometers on a stick that you can swing around. Okay, but one is just a normal thermometer, dry bulb, and the other thermometer has a little wet piece of cloth on the end. Okay, so what's going to happen when you swing this thing around? The dry bulb's just going to measure the regular temperature, but the wet bulb is going to cool down because water is evaporating off of this little cloth. And it can tell you how much tell you how much moisture is evaporating into the atmosphere by using your ESRT. It's called a sling psychrometer, and this helps you measure your dew point and your relative humidity. Okay, so dew point, once again, is the temperature you must reach to be full, and relative humidity is what percentage full are you. Okay, and this is another type of barometer. We also have this one in our classroom on the windowsill. Okay, this one, if you look closely, it's very small, but it has inches of mercury and millibars. Okay, and it says it's also called a barometer, and this also measures air pressure. Okay, you'll notice that the lower pressures like 990, 980, 970, 950, okay, this is stormy and rainy. Low pressures, lousy, low, warm and wet. But then you have these higher pressures, 1010, 1020, 1030, 1040, dry, okay? It's not going to be raining there because the pressure is high, okay? All right. Hopefully that one was pretty straightforward. Let's move on to number 42. This one probably caused a lot of problems for some of you. You have to just use your ESRT. The answers are right there, okay? So just decode the station model below. So if you were looking at a map and you saw this doodad, okay, if you, according to your ESRT, just remember, I'll show you really quick. Whoop. You're gonna make me struggle here. There we go. All your information on your station model is right here. So it tells you where the temperature, barometric pressure, blah, 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 blah. So if you need help, that's where you should look. So let's roll. Oops, there we go. So if you found this on a map, what would you do? Well, I always start at the top left. I mean, you don't have to, okay? But that is where they started. Temperature, this is the top left. That would be 70 degrees Fahrenheit. But Miss, you said that we do Celsius. I know, but these are used in America, so we use Fahrenheit. And it is labeled on your ESRT. And notice how there's no labels on this little symbol, okay? That's on purpose. Okay, visibility is right here to the left of the circle. Okay, that's 3/4 of a mile. Okay, dew point is the bottom left. That's 61 degrees Fahrenheit. Present weather, that's this symbol to the left as well. It's this little infinity pattern. If I use my ESRT and I go to that page again, whoopsies, let's look. the infinity pattern right here, Haze, okay? The infinity pattern on your ESRT is a little fatter, okay? Don't body shame him. All right. So haze, cloud cover is just what percentage of the circle is shaded. Okay, the shaded part is the cloud cover, the clear part is the clear part. Wow. Okay, 25% is covered, so cloud cover is 25%. Okay, wind direction. The stick points the direction the wind is blowing from. So we would call this a south wind. So the wind is blowing from the south and it actually is blowing to the north. Okay, wind speed. Okay, that's these things called feathers. A long feather means 10 knots. A short feather means 5. Okay, this has one long feather, so that would say 10 knots. Don't get all huffy about knots. It just means a wind speed, kind of like miles per hour, same thing. Okay, well, okay, not same thing, but similar. Okay, it's a way to describe how fast you're going. Excuse me. Barometric pressure, that's the top right. Okay, this is where it gets tricky. You have to change this number, okay, because 0, 1, 2 is not a barometric pressure. Remember the rule. If this number is below 500, you add a 10. If it's above 500, you add a 9 in front, and then you put a decimal between the last two, remember? 12 is below 500 last I checked, so that's why they added a 10 in front, 0, 1, 2, and then they put a decimal in between the last two, and that's millibars, okay? Barometric trend, we got a minus, so that means decrease. So in the past 3 hours, what's happened? You just put a decimal point in between these two, 0.1 millibar decrease. So it's the pressure's gone down, okay? And precipitation, well, if there was precipitation, it'd be right here in the bottom right, but since the bottom right has nothing, there is none, okay? These aren't that difficult if you just take your time and go piece by piece. So now, this is when you were supposed to draw one, okay? So it tells you temperature is 46 degrees F. You have to write 46 on the top right. Make sure you do not put any units over here. Visibility, 1/4 mile, 1/4 mile. Dew point, 45 degrees F, okay? Present weather is rain. That's what this dot means. You can find that on your ESRT. Cloud cover is 75%, so you would color 75% of the circle. Okay, the wind direction is northeast, so you would draw your stick to the northeast direction. Okay, your wind speed, 25 knots. So 2 big sticks is 20 knots, 10, 20, and then a fiver, a short one, it would be 5 knots. So 10, 20, 5. Okay, they gave us the pressure as 9,969. So I take the last 3 numbers, because remember, we added a 9 or a 10 in before. We're going the other way, so we have to remove the front 9 or the front 10. So I'm going to remove this front 9, and I'm left with 969. And I'm just going to get rid of that decimal point. I just do the opposite of what I did last time. Okay, so now this number's more than 500. That's why they added a 9 in front. Okay. We have a decrease by 0.6 millibars. So decrease by 0.6, you take away the decimal point. No decimal points here except for the precipitation in inches. Okay, 0.15 inches, bam. Okay, so it's really not too bad. Like I said, you just got to take your time, look at each piece, and make sure you do what you have to do. You'll notice that, what do you notice about this? The the temperature and the dew point are very close. They're only 1 degree apart. And that's why there's lots of clouds and it's raining, because you're almost at the dew point. So you're almost full. That's why you're going to have much more increased precipitation. But this one, 70 and 61, you're 9 degrees apart. So you're not really close to the dew point. So you're not full. You're a little full, but not completely full, okay? And that's why you're going to have much less precipitation, if any, okay? Okie dokie. That was number 42. 43. 44 you can't do. 43 we did do, right? Let me just double check. Yes, yep. Okay, 43. This is station models, the same thing we just looked at, but now we're just looking at it on a map, okay? It means nothing different. So we have locations A, B, C, and D. We have some other locations here throughout the state, okay? We have these lines, which are millibars. Okay, we call these isobars. It says state the actual air pressure in millibars at station A. Well, if I go to A, I look at the circle, the pressure is to the top right. So we have this number 209. Well, 209 is less than 500, so I'm going to add a 10 in front, 10, 209, and you put a decimal in between the last two, and shabam, 1020.9 millibars. Okay, that is actually in your notes too, so if you're like, what is she talking about with this rule thing? That's where I got it from. Okay, what was the wind speed? What was the wind speed was recorded? That was recorded at station B. Okay, let's go to station B. The wind speed, we have to look at the feathers here on the stick. We have one big stick and one small stick. 10 plus 5 is 15 knots. Okay, which station had the highest relative humidity? So which one was the most full? Okay, rainy. So, so we have station A. A has no clouds. Okay. B has half clouds. They're pretty far apart, these pressure or dew point temperature and air temperature. Okay, this one has 3/4. That one's, I mean, the more clouds you have, the more likely you are to be full. So, but the one with most clouds should immediately make you think, oh, C. Okay, it also has the lowest pressure. Lower pressure, lousy, low, warm, and wet. Okay, these are higher pressures over here. These are lower. Lower pressure, full cloud coverage. And look, the air temperature and the dew point temperature are only 1 degree apart. So you're almost at the dew point. You're almost 100% full. Okay, so you could have described this a few ways. Okay, the highest relative humidity was station C. You could have said because the cloud cover was 100%. Because the air temperature and dew point were closest, because they were only 1 degree apart. You could have also said it had the lowest pressure. I would also accept that, okay? What was the probable air pressure in millibars at station D? So station D right here. It's in between the 1012 and 1016 millibar. So I would accept anything between 1013 and 1015. You should know how to do that because of your contour line practice. Okay, I would not accept 1012 because it is not on this line, and I would not accept 1016 because it's not on this line. Okay, it has to be between. So 1013 to 1015. Okay, which New York State weather station had clear skies? Okay, so New York State. So we're focused right here. That one's not in New York, by the way. Okay, New York, clear right here. Bam. How the heck am I supposed to know where that is? It doesn't tell us. Well, you have an ESRT for that, okay? So I don't know what city's there, so I need to go look. Boop, 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 at my New York State map. Okay, over here, right there. Bam, Albany, right there. Okay, see how it matches up? So the answer is Albany. Okay. Oop, oop. Which weather station had a wind speed of 10 knots? So we're looking for one long stick. That's, oh, look, this has one stick. This one has one stick. This one has one stick. Do you notice how the stick is not on the very end? They do that because these are actually 5 knots. This is half of a stick. Okay. They put it, if it's not on the end, it's not a big stick, okay? So one big stick on the end of, one big feather, excuse me, on the end of the stick, one big stick, notice it's on the end, that would be 10 knots. So the correct answer is station D. Okay, what is the wind direction for New York City? Okay, well, New York City, if you don't know, is right here. If you didn't know that, you could use your ESRT. Okay, the wind direction, you have to look at the stick's direction. The stick is pointing to the north. So we call this a north wind. The wind direction is north. Okay. Using a weather instrument, a student at location in New York State determined the dry bulb temperature to be 10 degrees C and the wet bulb temperature to be 6 degrees C. Determine the dew point temperature and relative humidity at this location. Okay, so we got 10 and 6. So this is I love this. I'm glad it's on here because we need to use our ESRT. So 10 and 6. Notice how the dry bulb is 10, the wet bulb is 6. The wet bulb is always going to be either the same or lower. It's never going to be higher because remember, you're swinging that sling psychrometer around. It's evaporating off of it. It's a cooling process. Evaporation cools you down. Okay, so 10 and 6. Let's go for dew point and relative humidity. Boop, 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 boop. Okay, oops, that's not what I wanted to do. No, stop. All right. Okay, dew point, relative humidity. No, I passed it. Oh my goodness. Oh my gosh, I'm terrible at things. All right, nope. Where the heck is it? I hate doing things on the computer. View, hang on. Let's do single page. Now my brain can hurt less, maybe. All right, here we go. Whew. All right. So remember, always be careful. Dew point's on the top. So let's do dew point first. So dry bulb temperature on the left-hand side here is just your dry bulb. Our dry bulb was 10 right here. Oops. Okay, 10. And this one is the difference between your wet bulb and dry bulb. So 10 and 6, the difference would be 10 minus 6 is 4. So you go down to where those two numbers would meet, 10 and 4, and you get 1 degrees Celsius. Okay. Now you do the same exact thing here with relative humidity. Okay. You go to 10 because it's just your dry bulb. Okay. And then you go to your difference. 10 minus 6 is 4. You go down to where they meet and you get 54. Okay. So hopefully that's our answer. 1 and 54. Make sure you write them in the right spots, by the way. Okay. So let's see. 1 and 54%. Awesome. Okay. So that's it, guys. I hope you guys did well on this. If you didn't, hey, you tried. It's tough. Okay. Don't get discouraged. Stay with me. Okay. We'll get through this. And I hope to see you guys soon.